Hey everybody, this is Larry. This is day 12 of the November Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Today we have 2654. I didn't do much today. Happy Veterans Day. Hope y'all, I don't know, celebrated or whatever. I mostly just rest today. I actually walked around this. It's actually really cold. I went for a quick run, but I also just walked around the city doing more shopping again. I had to return a jacket to get a slightly bigger one. Yeah, I had to, I had to get another jacket because I forgot to whatchamacallit, I forgot to wear the jacket on top of other stuff in layering, so it was too small when I had everything together. I think everything's fine now. I hope. I mean, either way, it's too late. It's already going on the trip, so we'll see. Yeah, and hopefully tomorrow I just kind of remember everything else. But yeah, all right. Let's just take a look at today's farm. I'm starting to pack, and it's kind of getting stressful. Honestly, packing is always super stressful for me. But we'll see how that goes. And in a couple of days, you'll see me in a different city. Anyway. Let's take a look at today's problem. We have 2654, minimum number of operations to make all array elements equal to 1. Alright. Is that what we did yesterday or 2 days before or something? I don't know. Alright, let's take a read. Okay, we have nums, we have positive integers. You could do an operation all times. Select I, and replace either I or I plus 1 with the GCD value. Okay, and GCD, I guess, gets smaller over time. Not always, but it's at least the smaller of the two values, right? Probably, yeah. Okay, in any case. And it doesn't always have to be possible. For example, if they're all the same number, that's non-1. Then, if they're all 5s, for example, then, it'll just be all 5s. Okay. There are 50 numbers, which is interesting, right? Honestly, because I actually was already thinking about strategy. Like if there, I mean, with n is equal to 50, maybe. I mean, it's hard to say because with a medium, it might be that there is a harder solution, just that maybe it's not a medium difficulty solution. But immediately, I was already thinking about strategy because if n is say 1,000, then it's going to be like some n square strategy, maybe still greedy. If its n is like 10 to the 5th or 10 to the 6th or whatever, then definitely I'm thinking greedy because there's no other way, really. I don't know, right? Or like strategy-wise. I mean, greedy can mean different things in different contexts. So it might, like even if you're just sorting, maybe that already gives it a structure and maybe that already makes it a greedy solution. Anyway, that's just semantics anyway, right? At the end of the day, you solve it or you don't. Sometimes people get caught up on these definitions sometimes, and but for me, of course, I have to be a little bit more pedantic because I am trying to hopefully teach people a little bit of something, and maybe myself as well, if I can. But if I wasn't for other people, maybe I don't need to be that pedantic, right? And at the end of the day, you just need to solve things. Okay. So. Okay. And also, by the way, you can sort this, right? I mean, I think that's obvious, right? With I and I plus 1. What happens when you replace one of them with the GCD? Right? Well, one thing is you wouldn't do it again, right? Meaning that, like, if you picked I, you wouldn't pick I plus 1 again, unless there's another change. And then the question is whether that propagates. N is equal to 50 is kind of interesting. Of course, immediately it makes me want to do some kind of brute force thing. But I don't know that I know how. I think another thing that I would consider is whether there is a possible, or like in this case it does say minimum number of operation. What I wanted to mean by that, doesn't matter, is that maybe there's only one way to do it, right? Or not one way, but one effective way, right? Meaning like, okay, maybe you do I and then I plus 1, or the other way around, maybe gives you the same answer, right? But you only replace one of them, so it's a little bit tricky. Huh. But yeah, but I guess like the thing that I'm trying to think is, doesn't matter, right? Meaning that, like, it may be that, for example, here, no matter which way you do it, as long as you don't choose something trivial, you always get an answer. One thing I would say is, and maybe I didn't necessarily spot it immediately, is that once you have a 1, then all the other ones, you can cancel it out, or not cancel it out, but just go it that way. So then maybe that is a strategy that I didn't really think about it. I mean, maybe that is a strategy, right? Where maybe it also fits with n is equal to 50. You kind of brute force a sub-array that gives you a 1, right? And what I mean by that is that my idea with just what I mean by sub-array is that, like, I mean, in this case, 3 and 4 already have the GCD of 1, so then we can already find a 1, then we can propagate all of them. And because we're trying to make them all 1s, I guess you have to find the first one. And once you find the first one, you're good. Okay. I think that part, hopefully you followed so far, I think I'm okay, right? Meaning that if you're able to get 1, 1, then problem solved. Then you just kind of, one operation for all the remaining ones, right? So you have to find the first one. And obviously, in this case, 3 and 4 is trivially, like they're next to each other, so you could make one of them, it doesn't really matter, right? But then the question is, well, what happens if you don't find a pair? Well, the thing is, and that's what I mean by sub-array, is that, well, you can propagate it out, right? For example, you have, the key observation here is that you have ABC, right? Well, GCD of AB, and maybe another way of saying it is GCD of ABC is equal to GCD of AB, and then GCD of this of C, right? And it doesn't matter. Like, the order doesn't matter. It's commutative, distributive, whatever, right? With GCD, right? But what that also means is that what that means is that we are able to find a sub-array in which, maybe if you find a sub-array that we want to, like, okay, maybe if this has a GCD of 1, I added a thing for no reason. If the sub-array ABC has a GCD of 1, that means that if you GCD A and B, update B to whatever A and B is, the GCD of A and B, and then do this with C, then it will also give you 1, right? Because that is the equivalent of, GCDing A and B, put the result in B, and then do C. And I think that gives us a footprint for an idea, right? Because then now another way of phrasing is find the. Let me write it down as I'm saying it, right? So then now another way of phrasing it is find the smallest sub-array that gives us GCD of 1, right? And why did I jump to this? The reason is because then now if you need 3 numbers consecutively, sub-array, if you need 3 numbers in the sub-array that gives you GCD of 1, that means that, okay, then now let's say C is 1. And then now all the other numbers, and maybe we have a lot of numbers to the left, a lot of numbers to the right, we can just go through all of them and give an A and B, right? And you just do the math on the operations. And of course, in this case, because you have to carry the A and the B and all the way to C, but so the fewer numbers you have in this sub-array, the fewer numbers that you have to do to kind of, that means that the fewer number of things that you need to do to get a GCD of 1, right? Before you propagate it back out, keeping in mind that if you make D1, you still have to make D1, C1, so it still takes operation for that sub-array. So then now, in that way, you can say that the cost is going to be N, and maybe I'm off by 1, I'm just kind of like high leveling it, right? And because every number has to go to 1, unless you already have a 1, obviously. But there are some. It's not everything, but let's just let's just say nothing is 1. The cost is going to be n. Plus the size of the subarray, right? Does that make sense? Because or maybe -1, but you get the idea. Because here we first, if the subarray size 5, I guess we do 4 operations, so it's just -1. But like I said, I'm not worrying about that. If the subarray is size of 5, then the size of the if the size of the subarray is 5, then it takes 4 operations to get a 1, and then an n-1 operation to do all the other ones, right? So I don't know what maybe it's off by 1, but you get the idea. So that's kind of what we are going for. Okay, so I think we're Gucci. So let's just say we go so okay, if 1 let's say 1s is equal to nums count 1. So we just want to count the number of 1s first. If 1s is greater than 0, then we're done. It is just return let's just say n is equal to length of nums. Then n, is it -1s? Yeah, because basically and they're all non-zero, right? Just want to make sure, because if this is 0, I don't even know how. But yeah, I think this is right, because then now yeah, right, because then now if they're 1-1, then it takes n-1 operation to get all the other ones. Yeah, should be right. Maybe I'm wrong, but easy to check otherwise later. And then now we find the smallest subarray in which all the GCD is 1, and we can just do this, right? The smallest, so we want the smallest, so we do an infinity is equal to n, whatever, right? Actually, let's just make it a big number. We talked about this a couple of times, I think, the last couple of days. Definitely a pattern that you have to know, or idea anyway, right? So then we have the current G is the GCD, right? Oops. Right, and then now if G is equal to 1, then best is equal to min best n-start plus 1. And of course, there are, you can early terminate, etc. On the end loop, but whatever. And then now we just return best plus n-1 or something like this. Like I said, I may be off by 1 here, actually, to be honest. And maybe I should think it out. Yeah, I think I am. Well, oh yeah, I forgot about that case actually. That's the reason why I changed it to infinity, and I just forgot about it. But that's okay, because I knew that was in the input or in the example. I'm really tired. I don't even know why. But yeah, we're off by 1, right? Because it's n-1 and the best -1. This takes whatever. And then going through the rest, that's not this one, because it assumes that we have only 1-1 after converting 1. So yeah, so this makes sense to me. Let's give a YOLO submit. And okay, there you go. Apparently, still a slow solution. Can I go faster? I'm curious though. I did better than last time. We had 3 wrong answers. I got it right this time on the first go, which is nice. What was I thinking of last time? I did the ones thing. This looks exactly. Oh wait, this is weird. This is just like the. I don't know why. I know why this is wrong, because we return early for some reason. That's not even return early. This is return n. So I don't know. I don't know what this code was. Maybe I had some other logic. Maybe I have to watch that one. But I guess eventually I just Wow, this is crazy talk. I mean, I think this is probably the same idea, but maybe I didn't think through what that means, and I just calculated instead. Did I simplify it? Oh, I guess I did end up simplifying it. No, I didn't. I still n cubed. But today it is n squared, so it is faster. I guess I didn't go over the complexity. My bad. Yeah, it's gonna be n squared. Obviously, there's GCD, O of one space, and that's it. That's all I have with this one. This is a very tricky one to kind of go through. What are the hints anyway? Okay, that's basically what I was trying to do. Eventually, yeah, that's what I was doing. Can you do this in linear time? Actually, I don't know if you could do this in linear time. Not good at GCD. I guess sliding window, but you have to be careful with sliding out. I mean, it's possible, but I don't know. Yeah, I don't know. Anyway, that's fine. That's all I have with this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.